All right, welcome to day 3 of the Unit 1 homework packet. We're looking here at pages 5 and 6 in the homework packet. So Lewis dot structures, the biggest thing for Lewis dot structures is we only care about valence electrons. Valence electrons, okay? So I'm going to come over here and look at this one with y'all. This is anything that has 2 valence electrons. So that's going to be group 2 or 2A. Okay. So I would really never put an X there, but I could make Be, Mg, Ca, strontium, barium, radon. All of those guys would be okay. Sorry, radium. I was thinking there. So the group name for group 2 would be the alkaline earth metals. Okay. So we're going to come down here. I want to look at chlorine with you. Don't put X, right? You put the symbol in the middle. So if I know it's chlorine, I put chlorine. If I'm just talking about the entire group, that's why we used the X as an example. But chlorine, I put the symbol in the middle. And then we're going to come find chlorine on the periodic table. It's a member of group 17, which is known as the halogen family. And so it has 7 valence electrons, 7 dots to put around. Now it does matter the order you put the dots in. You'll get more explanation of that in next unit. But the first 2 electrons share a bedroom. It can be on top, or like here they put them on the side. It doesn't matter where around the orbital, or excuse me, around the symbol, as long as they're together. And then electrons 3, 4, 5 go by themselves, and then 6, 7, and 8 will share. So in this case, we have 7 valence electrons. I'm going to just put it on the side to be different. I'm going to put 1 and 2 here, and then I'm going to go 3, 4, 5, 6, 7. So basically you should notice, and you don't have to put this, but you should notice I'm missing an electron right there. So I would know by looking at chlorine's dot structure it needs 1 more valence electron. Okay, so the same thing over here. Alright, I'm actually going to do nitrogen as well. I wasn't going to, but nitrogen's a weird one. Nitrogen is in group 15. So if we're looking at group 15 on the periodic table, okay, so over here, group 15, I was saying, nitrogen has 5 valence electrons, so they're kind of the weirdest ones to put. I'm going to show you what it should look like, and I'll do it according to this. So the first 2 electrons go next to each other. They share a bedroom. And if mom and dad are sharing the bedroom and you have a kid, they get their own room. Electron 3. Electron 4, my boys do not like sharing a room. Trevor is going to want his own room. 5, like this. Okay. So let me show you a bad example in purple. It is not like this. 1, 2, 3, 4, 5. Okay? These 2 are not going to share a bedroom if there's an open bedroom over there. So make sure it's 1 on each of the other 3 sides. Looking down at number 5 and 6 here for isotopes. Remember, isotopes are awkward. They introduce themselves with their mass. So this guy's saying, hi, I'm Krypton. I weigh 68 pounds. You're like, awkward, Krypton. I don't need to know how much you weigh. 68 AMUs, right? That's our unit. So looking down here, what do we know about number 5? We know element 54, atomic number 54. So if we've done 54, that's xenon, Xenon. Xenon dash, and we're going to need a number here to show the isotope. Okay? So I can say that it's Xe for the symbol, but I also need a number up top and a number down below. So the number at the bottom is going to be the atomic number, so that's the number of protons, 54, and I don't know the mass. I don't want to look that one up. Okay? So I know that atomic number A equals P equals E, ape man. So I know that all 3 of these ones should be 54, and then they also told me that there are 82 neutrons. So if you grab out your calculator, or do it mental math, right? 54 plus 82 equals, nope. Darn it, let me try that again. 136. So the mass number, not the rounded, but the actual mass number that I know, is 136. Right. If we're looking at xenon on the periodic table, the average xenon weighs 131.294. That's like saying my average class this year has 25.88 students. There's no such thing as 0.88 students. My 5th period class has 27 students. So I can say specifically this xenon weighs 136. Okay? So hi, I'm xenon. I weigh 136 AMUs. Looking down here, I know that there's 10 neutrons and 8 protons. So that means the atomic number is 8, and there's 8 electrons. Number 8 is oxygen. O-X-Y-G-E-N dash. Okay. Electrons are like earrings. They don't change the mass, but protons and neutrons do. So even though the average oxygen weighs 15.999 AMUs, this actual mass number of this specific oxygen atom would be 8 protons plus 10 neutrons, 18. Okay, so I'm going to say it's oxygen 18, the symbol right there, O. Down below would be 8, and then up top would be the mass number 18, which reminds me I forgot that up here. So I'll put 136 on top. Okay, so for this kind of notation, it should be mass, number, protons, and then the symbol. Okay, so the top number is the mass number, the bottom number is the protons or the atomic number, and then the symbol is there. Okay, lead 206. So this is lead saying, hi, I'm lead, I weigh 206. It's a byproduct of a certain nuclear reaction. How many neutrons, how many electrons? Okay, that's not enough information to answer this question. First, we have to find lead on the periodic table. It's a hard one to find because it's plumbium, I think is what it is in Latin. Pb, that's why lead is Pb. So plumbium has 82 protons. Okay, so 206, 82 of those are protons. So eighth man again. I'm going to say mass minus atomic equals my neutrons. So 206, my mass, minus my atomic number. Okay, just to say it a different way, I weigh 206, 82 of them are protons, so the other 124 are neutrons. Okay, which means if I have 82 protons, I also have 82 electrons. Which of the following properly describes the structure of potassium-40? The 40 is not the number of protons. That is not true. There is no such thing as potassium with 40 protons. Every single potassium has 19 protons, or it's not potassium anymore. So A is garbage, 19 protons, all of those looks good. Okay, remember protons should equal electrons. So 19 and 21, that looks like garbage. 19, 19, 19, 19. Okay, so I've officially eliminated these two options. Okay, potassium 40 doesn't mean 40 neutrons. Potassium 40 means it weighs 40. So I would say it weighs a total of 40 minus how many of them are neutrons equals how many left over are neutrons. Okay. This is perfect examples of test questions right here. That's what we expect you to know from this unit. Let's look over at page 6. Okay. Which properly represents the potassium-39 isotope? All right. Potassium that weighs 39. Which means it does not have 39 protons or 39 neutrons. Okay, the answer is not 39. Potassium that weighs 39, in order to be potassium, has to have 19 protons. So I know that it has 19 protons, not 20 protons. So the total mass, 39, minus my protons equals my neutrons. So in this case, 39 minus 19 equals 20. D. Atomic mass of copper, for all of these ones, you're just practicing looking at these elements, and then AMUs, atomic mass units. So we're going to find copper right here. 63.546 is what the average copper weighs. An isotope of copper can weigh more or less than that. Lead, again, is plumbium in the Latin. I think that's how you say it. So it's Pb. It's a hard one to find until you get used to it. Weighs an average of 207.2. Alright, let's look at some of this pen stuff here. Again, this top number, this is the mass. This is the atomic. So mass minus atomic equals neutrons. So protons, we're going to copy, calculate for this one. 92, 92, and then calculate for neutrons. So 238 minus 92, 146. Okay, when I add all of this back up, except for my earrings that don't count, it should equal the top number again. Okay, so I'm going to copy, calculate. So 47 goes to both of these. That's the protons and the electrons. And then mass minus atomic equals neutrons. 108 minus 47 equals 61 neutrons. Okay. And that's just getting used to reading this isotopic notation like that. All right. Thanks, y'all.